Let's take a look at your practice quiz for Focus 3 on exponential functions. Number 1 says for us to graph the exponential function below and identify the key characteristics. So on your quiz on Tuesday, you're going to be asked to identify 2 of these key characteristics. So I'm not going to tell you which ones they are. I just want to review all of them with you so you'll be prepared. So let's type in, I've pulled up Desmos over here to the right. Let's type in our equation. So y equals -2, and then in your exponent, so I hit that little a to the b power button. I need to put a parentheses because the exponent contains more than one term. I need to put x plus 6 all in the exponent. Then drop down with the arrow key and put -1. That way I get the correct graph to show up. Then you can hit the home key if you need to make it come back to like a normal looking window. And we're trying to find, well, first let's plot the graph. So let's get some points. Let's see, maybe, let's see, that's -10, -1, like close to that. So let's plot that point. Let me switch colors. So -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, -1. Then it looks like it's at -5. -3 is another good point. So 1, 2, 3, 4, 5, down 3. And let's find another good point on the graph. Let's see. Like maybe -2, -18, but that would be too far down. So let's do -3. Looks like it goes with -9. Like right, yep, right there. -3, -9. So -3, -9 is about right there. So you want to get a couple of key points on your graph so you can plot them correctly. And then it says x-intercept, y-intercept, domain, range, and asymptote. So with Desmos, I'm going to make it a little bigger and hide my function for a minute. So I can see that the asymptote is this line at y equals -1 because it never goes up past -1. So let's write the asymptote is at y equals -1. And then the range would correspond with that because the range goes from -infinity, as you can see, up to -1. So we would say the lowest point on the graph for the y is at -infinity because it never actually stops. Then it goes up to -1, but it won't equal -1 because that's our asymptote. So let's put a parentheses. The domain would be all real numbers because this graph is going to the left and the right forever. And we can drag it and see that that does keep going. And then we need the y-intercept. So let's find it down here. Looks like it's at 0, -65. So that's easy enough to find. And then the x-intercept, notice it comes up here to -1, but it won't go further up. So it does not ever touch the x-axis. So let's say none. So on your quiz, we're going to ask you about 2 of these key characteristics of your graph. So I hope that helped with an example. Let's look at number 2. It says a population of 230 rabbits increases at an annual rate of 36%. Write an exponential function to model the population of rabbits. I'm going to move Desmos out of the way. Write an exponential function to model the population of rabbits. How many rabbits will there be in 8 years? So if you just want to model the population, and it's just an annual rate and it's increasing, that's just the growth formula. So let me write it the way it looked in your notes. But remember, it doesn't matter what letters are actually there. They represent the same thing. All right, so this on the left, no matter what letter we use, that's going to be the final amount. Then what's just across the equal sign is always going to be your initial amount. It doesn't matter if they call it P or whatever letter they decide to use. It's not important. That is the initial amount. And then R is the rate. And T is time. So we're going to plug in what we know. So we know a population of 230 rabbits. So that's the initial amount. 230 rabbits increases at an annual rate of 36%. So remember, we changed that percent into a decimal to write it. So your decimal right now is behind the 6. We need to move it over 2 places to the left. So we'll say 1 plus 0.36. And then we're just going to write the function. So we're just going to leave the t and let's just write y equals. And if you make the t like an x, it doesn't matter as long as that's written out. So that is our function. But then it says, how many rabbits will there be in 4 years? So don't forget to plug in the 4 and figure that out. So we're going to put in 4 years for time. And then we're just going to type that in the calculator. So let me grab my graphing calculator and bring that up here and clear out that stuff. So 230, 1 plus 0.36, and then to the 4th power gives me 786.8. So it's rabbits. Let's just round up to 787 rabbits. Okay, so that's it for number 2. Your bank is offering a savings account with a rate of 2.5% compounded quarterly. So when they say compounded quarterly, we need the compounding interest formula. So that's A equals P 1 plus R over N to the N times T power. And then N is the number of times a year that your money will compound. So quarterly is N equals 4. N equals 12 if they say monthly. And N equals 2 if they say twice a year or biannually or semi-annually. Those all mean twice a year. All right. So those are just a few of the typical ones, but it's how many times a year the interest will compound. And then the other letters still mean the same thing. So the A on the left is still your final amount. P is still your initial amount. R is still the rate. And T is still time. That new letter is just the N, which is number of times a year your money will compound. The interest will compound. So a bank is offering a savings account with a rate of 2.5%. So we're going to make the rate into a decimal. So 2.5, if we move the decimal over 2 places to the left, then our rate is 0.025. We deposited $1,600. So that is our initial amount. So we have 1 plus 0.025. And we're going to show the function. And then we're going to plug in the time of 11 years. So let's see. We've got A equals 1,600, 0.025. And it was quarterly, so we're going to divide that by 4, and then to the 4 times t power. That is our function. That is just right before you plug in the time of 11 years. So now let's plug in the 11 and answer our question. So 0.025, it all looks the same. We just need an 11. And then like I've told you in class, go ahead and multiply the 4 times 11 so you make sure not to make a mistake when you type it in. So that would just be 44. So in my calculator, I'm going to type 1,600 parentheses 1 plus 0.025 divided by 4. And then make sure I take it to the 44th power. So I would get that my final amount after 11 years is $2,104. And since we're talking about money, round to the nearest 100th place. And that's it for number 3. Number 4 is an example of an exponent problem you're going to have on your quiz. So this one says simplify, and it gives us a quantity to the 6th power. So what we could do is take each part of this fraction to the 6th power. So let me erase that for a second and show you. So we're going to do m to the 3rd to the 6th. And then n to the 6th. Take each piece of the fraction and take it to the 6th power. And then simplify. So with that, you're going to multiply these exponents together. So I end up with m to the 18th power, n to the 6th power, n squared, and p to the 6th. But then we have a base of n on the top, our numerator, and on the denominator. So we need to subtract. So let's take m to the 18th, and then it'll be n, and that'll be 6 minus 12. And then p to the 6th is still in the denominator. So then we take m to the 18th, let's simplify, and that'll be n to the negative 6th power over p to the 6th power. And then one more move will help us to fix this negative. So that'll be m to the 18th. Oh, n will be on the bottom now. So n to the 6th, p to the 6th is on the bottom. So first we distributed the power, and then we had to subtract because we had a common base of n, and then we ended up with a negative exponent, so we had to move it to the bottom. All right. The last problem on your quiz review says that we have to solve for x, and we're given, there's Scout again. We're given an exponential equation that we want to try to make them have like bases on both sides. He really wants to be in my video. So 343 is equivalent to 7 cubed. So we can rewrite it as 7 cubed, and we haven't changed what we are given. But now both sides have a like base of 7, so you're allowed to cancel them out and solve what is left over. So we just have 3 equals 4x minus 9. Then we can add 9 to both sides, so we get 12 equals 4x. And then divide both sides by 4, and you get x equals 3. And then you can check your answer, but you don't have to check your answer. But you could just plug this in to make sure you have the right answer. And see if this makes a true statement. So in your original problem, just to make sure you got it, you could type in the calculator 7 to the 4 times 3 minus 9 power, which does equal 343. Now, if you have an older calculator, just keep in mind you probably need to put all of that in parentheses. So 4 times 3 minus 9, like group it all together in parentheses to make sure it treats it properly. All right, so that's it for